All right. Happy New Year, everybody. Welcome to 2026, the first day of school. We see a lot of students at UND, and it's kind of good to have them back again. So we do have a full spring schedule again this time, but we are going to start off with Dr. Jeremy Straub from North Dakota State University. He's an associate professor at the Department of Computer Science. We are going to talk about vibe coding. This is either you like it or you don't like it. That's what I'm hearing from people that I have talked with about this. So, Jeremy, please go ahead and get started if you're ready.
Sounds good. Well, I would add one thing to that. Is everybody hearing me? Because my little microphone is not showing. All right, that's good. So
Yes.
it's just the indicator that's broken, not the actual audio system. Um, so what I was going to say is I would add one thing to that. You can like it, you can not like it, but probably everybody is going to be doing it soon. So that's kind of the theme of today's presentation, vibe coding, and the future of programming. And again, just kind of talking about what exactly is vibe coding for those that are not familiar with it, and kind of what does that mean. So again, we have about 30 people here. I'm happy if you want to put questions in chat or interrupt with questions as I'm going. Otherwise, we can have some time to kind of talk about this more at the end as well. But please, if you do have any questions, please feel free to interrupt midway through if that works well for you. So if you're not familiar with the term vibe coding, at its most basic, we're talking about basically developing software with artificial intelligence. And what we're discussing here is an approach that is human on the loop. And this falls into kind of this continuum of terminology. It's very frequently used by the military, but also used in a lot of other contexts of human on the loop, human in the loop, and human is the loop. And so the kind of most human-centric approach is human is the loop, which means the human is doing everything, making all decisions, doing all the work. Human in the loop means that the human is involved in the decisions and is improving actions before they're taken. So the human is a key component of the loop. The loop does not move without the human. Human on the loop, which is the approach that I said vibe coding falls under, basically means that the human has oversight but is not directly involved in everything. So the human can say, hey, do this again, hey, you're doing this wrong, and certainly has the important role of kind of tasking, but the human is not looking at every line of code. They're not saying, oh yes, you can do this, yes, put a semicolon there, etc. That is left to the AI to do. So vibe coding, again, kind of key takeaway from this slide, it's developing software with artificial intelligence and using this human on the loop approach where the human is integrally involved, but not doing everything and not necessarily approving everything before it's done. So what does vibe coding mean? And maybe before I go too far down this, I probably should have done this before the previous slide. Just with a quick show of hands, using the little indicators in Zoom, how many people are familiar with vibe coding, have used vibe coding, have heard even the term? I'm seeing about 4 or 5 now. That have done it. Okay, just to make sure I'm not spending too much time talking about stuff that people are already super familiar with. So it sounds like we do need to spend a little bit of time talking about this, and that's fine because that's kind of how I was anticipating the presentation was going to go. But definitely wanted to check before we spend too much time talking about it. So the vibe coding approach is pretty straightforward, and it's not too different from what people in kind of lead developer or development manager roles are already doing. You start by doing kind of the design work, and we'll talk a little bit more about this, but I mean, AI can be very helpful in the design work, but we need design. We need to identify our objectives, our requirements, our constraints. We need to figure out what we want the piece of software to do. Now, there is what is sometimes referred to as one-shot development, where you basically come up with a single prompt. So you could go to a AI coding tool and say, hey, make me a word processor, and it would probably do it. Now, it wouldn't be the word processor that you necessarily wanted. You might get Notepad, you might get Notepad++, you might get, something with some features you want, maybe some features you don't want, missing some features you want, and so forth. But you'd get a word processor. The tools are good enough to do that. And in most cases, the word processor would work. So that's a good thing. If you give it more detail, you're more likely to get what you want and have it work the way that you want it to work. So this creates a much bigger focus on design than perhaps we've seen, recently. Well, a lot of design or a lot of software development firms, or what I was going to say, design houses, which isn't really a correct term. I probably should have said software houses or software design houses. Have taken a more iterative approach recently with some of the more modern iterative development models. And you can still do that with AI. It's just the more you give it in terms of instruction up front, the more likely that the first iteration is going to be close to what you want. Again, if you say, make me a word processor, it's going to make you a word processor. It may just not be the word processor that you want. The second step of this is letting the AI develop the code. And this is the thing, this is the magic moment, so to speak, of the whole process, because AI develops code really quickly. And so, having done this myself, thinking about things where I would give, a team of students or few junior developers a project, and then they would go away and they would work on it for weeks. It would take them, weeks and weeks. And by the time they were done, I would have, kind of lost context on what I'd asked them to do. I wouldn't remember exactly the details. I'd have to kind of refresh myself with notes, etc. And they would have to spend a lot of time, maybe getting up to speed on the particular tools that they were using, on the particular development framework, APIs they may be calling, etc. You can do the same thing by going into, so any one of the several tools that are designed for this type of thing, and simply giving it your instructions. And sometimes it will take 10 or 15 minutes, but it will do what may have taken a team of people, a week or 2 weeks to do in that time. And so, not only is this fast, and that's great, and it also sometimes has the same issues that junior developers have in terms of bugs and misunderstood assumptions and whatnot. But the thing that I like about it so much is the fact that I still remember what it was I was doing by the time they're done. So when the system comes back and it says, okay, I've gone through 3 or 4 iterations of development, test, finding little glitches. A lot of the tools do integrated testing. So you'll have those iterations of it, making code, starting the application, doing some assessment of the application itself before it says, yep, okay, this looks like it's what you wanted. But again, even if that's 15 or 20 minutes later, that's not weeks. That's not, I've been doing 5,300 other things in the time, and I don't remember what it was exactly I had asked for before. It allows me to kind of come back to it a lot faster. And again, see if it's what I was expecting that was produced or not. And that brings us to the third part of our vibe coding approach, which is testing, validating, and refining everything. And this is a very important part. Even if you have really good design documents, you've created wireframes of all of your screens, how you want them to work, you've created flow documents, and again, you may not need quite that level of detail for most vibe coding projects, but you still are going to have an opportunity to correct. And that's really where the other aspect of this comes in that's really neat and really powerful, which is of course you need to do functional testing, you need to do security testing. We know that there are a lot of security issues with vibe code right now, and the problem is, of course, the tools they have learned very well from the code that they've been supplied, and they are making exactly the same mistakes, and maybe even quote unquote better mistakes, meaning bigger mistakes from it. So we know that there are security issues with vibe coding produced results. Testing, to make sure that you don't have those types of issues in your software output is very important. Testing to make sure that it actually does kind of what you expect, that it meets the functional requirements, also important. Typically, the tools, from my experience, do a better job of meeting the functional requirements than necessarily meeting security standards. Again, they seem to be kind of more attuned to that. The industry also, started being very attuned to functional, and then security, unfortunately, kind of came in as an afterthought. And I think we're still suffering from the fact that there's an awful lot of, code out there where security was not the first thing, maybe not the second thing that was thought about, but the third or the fourth. And so again, we see some of that in vibe coding. But the real power here is the ability, because we can make these iterations so quickly, to take something, get it, working, and then take it out and share it with the stakeholders, to share it with the people that are going to be using it, the people that, may be relying upon information that's collected by an application, etc., and being able to get their feedback on it as well. And that's a very important aspect of this. And what we saw when we were looking at kind of the iterative code development prior to the advent of AI being involved in it is you would have people that would do mock-ups. Maybe they would make the user interface, but not actually implement anything behind it just to get feedback on the user interface. Or they would do other things that were kind of designed to be a surrogate for letting people play with a working application. Maybe they, if there was critical functionality they wanted feedback on, they would implement just that functionality, take it, give people kind of a verbal explanation of context, maybe mock up a few other screens so that the users could kind of see where a particular piece of code or section of an application fit within kind of the broader scheme, and then let the users kind of play around with and provide feedback on the particular area that they were interested in getting feedback on. Now we can make a mostly functional application, maybe even a completely functional application, get it out there, let people play around with it. Yes, tell them this is still under development, this is not ready for prime time, please don't put any real data in this because we haven't quite finished the security review yet. But getting people the ability to actually look at the code, play with the actual running code, and maybe even more important than looking at the code, being able to look at what's produced by the code in terms of the functional application, get the users involved, and get the application much closer to what the users want. Also, because the development resource is very low cost. You're paying for basically a subscription to a software service, plus the lead developer or small team or project manager that's kind of commanding it. You may have more ability to do iterations to make the application closer to what the users want, even after you get it to fully functional, which again would have been a very expensive process previously. So there's a lot of kind of neat stuff that we can do here, and again, a lot of capability that can be kind of unleashed. So hopefully this has been kind of an interesting overview of vibe coding for those that weren't familiar with it. Does anybody have any questions before I charge on just kind of about what vibe coding is, how it works, how you use it, etc.? All right, well, I'm not hearing anything, so I will charge on here. The next thing that I want to talk a little bit about is why we should care about vibe coding. So we've talked about a little bit about what it is. Now we'll kind of move into what does it mean? What are the implications? And so the thing that I think probably everybody can guess already from what I was saying on the previous slide is that it improves productivity significantly. It makes it so an individual developer can do a lot more app creation in a given period of time with a given level of quality. And so, there's always been this kind of notion of the three corners of the triangle where you have speed, cost, and quality. You can increase one or maybe even two, but you can't increase all three. When you can increase all three, that's a discontinuous change. That's something that is a change to the way the environment works. And of course, IT, information technology, has been doing this, basically for its entire lifespan. It's been continuously making things better, faster, and less expensive. And so AI coding or vibe coding does exactly that for code generation. We know that there are issues with the code that is produced. It's not to say that this is perfect, but the cost to actually get to a similar level of functional product is a lot less, which means we're able to do it faster, we're able to do it less expensively, and while we do spend time, beyond what would be necessary to have something that was not of high quality, assuring the quality, we're also able to produce something that is of higher quality within a given amount of time and a given amount of budget, because we're able to use the tools to help us do that. The other thing that's really important here is that vibe coding fundamentally changes the software development paradigm. I mentioned previously that design becomes far more important. And one of the things that I find really interesting about this is data modeling. And one of the ways that you can really get the vibe coding tools to do what you want them to do is to give them a data model, because it really locks them in terms of what they're able to do and how things work when you tell them how the data is collected, how the data interrelates, what types of data should be available to whom. So I think there's been a lot of movement away from strong data designs recently. We've seen things like no SQL databases where the idea was just put everything into this no SQL database, and then you can query it back out using free text queries, and you don't have to actually do database design anymore. That may not have been a great idea for a lot of applications, but it certainly was a direction things were moving in. Things like LLMs, where the LLM kind of knows a little bit about a lot of things and doesn't have a real robust data model, and that's where some of the issues like related to regurgitation, where it learns something but it doesn't learn exactly what the implications of the data that it's learned are. So again, we've been moving away from data models, and vibe coding makes data modeling really useful, also design really useful. If you give a vibe coding tool a good data design and a good kind of functional requirements, constraints, maybe some mock-ups of some key screens, that's going to really constrain what it produces. You're going to get something that again, it may have some functional issues, it may have, probably will have some security issues, but it's going to look and work pretty close to the way that you want it to. And most of the tools have the ability to upload files, they have the ability to upload graphics, so you don't have to figure out how to describe your desired screen look in text. You can just simply mock it up, draw the wireframes, use one of the wireframing tools that are out there, and just upload those to the vibe coding tool, and it will help you do what you need to do from there and make your application. The other aspect of this that I've already mentioned again is it's much faster. And as we were talking about just a minute ago, this means that we can approach the challenge of how do we make a piece of software differently. We can have more iterations of let's get this in the hands of the users. Let's see what the users think about it. Let's get more feedback on it. It also changes should we make a piece of software for this calculus? Something where it's going to take $10,000 to make is a very different question than it's going to take $100,000 to make. So by reducing the cost of software development, it may mean that software can be custom created for applications that just didn't make sense to do that for before. And so there's been a lot of discussion about the impact of vibe coding and AI coding on programmer jobs. But one of the things that may partially counterbalance some of the decline that this may cause in the number of jobs out there are the fact that making things cheaper may open up new opportunities for software development that simply wouldn't have been cost effective before. The last thing that's really important on this slide is it really changes the developer role and the skill sets that are required. The developer goes from being an individual who is producing code. Traditionally, lines of code produced has been a metric that's been used. Not necessarily a great metric, because it's a very easy metric to game. People split code into multiple lines. It should be one line. They produce, lots of unnecessary comments. They produce extraneous code, etc. So again, it's not a great metric, but it's no longer a metric when you're talking about an AI involved development environment. The developer's role really becomes one of interfacing with the stakeholders, translating stakeholder requirements, maybe disambiguating stakeholder requirements or deconflicting stakeholder requirements, and getting really good at explaining those requirements to the vibe coding tool or to the AI software development tool to help it actually make what you're actually trying to produce, what the users or what the stakeholders are looking for. And again, it's a very different role. And it's a role that has a very different skill set. In some ways, this is the type of role that we might have called a project manager, program manager, lead developer before, but it really takes little bits and pieces of all of these different roles, and the ability to interact with the stakeholders becomes quite important. So developers that kind of wanted to kind of go off and do their own thing and only interact with other developers or only get tasking from their lead, they may have a big problem in this environment. They will need to adapt potentially to be more involved in the interactions with the stakeholders, because that may be the lion's share of the work that needs to be done for a lot of development projects. So again, some tremendous changes that are happening in terms of kind of how all of these pieces fit together and kind of what is needed from a skill set perspective with vibe coding. I want to talk a little bit about the educational implications as well. I think the first thing to take away from this is that the software development as an industry is changing. It's going from something that was somewhat manually intensive, and of course, it's gotten less manually intensive over time. Right? We're not all still punching the punch cards and putting them through, the large, punch card readers, and writing assembly, and then figuring out which of the little blanks on the punch card allowed us to say a particular assembly command. So things have been better than that for quite some time. We then went to languages that were closer to the actual assembly commands, and over time we've created languages that do a lot more with a line of human generated code. And then we've also created a lot of frameworks, libraries, etc., that allow us to leverage previously created code. Well, we're taking another step towards abstraction, where the prompt is now becoming the abstraction of the development in a lot of cases. And where we are, like right now, snapshot of this moment in time, there are still a lot of issues with AI produced code. And so what you don't want to do is make a AI application, double click on it a few times, say, yep, this looks pretty good, and throw it up on the App Store. There have been a few people that have done that, and it has not worked super well in some cases. Now, there have also been a few people that have done that and sold their company for millions of dollars. So I guess, again, there may be ways that it works, but there certainly have been some cases where people have made vibe coding apps, in particular, not assessed their security either properly or maybe at all, and started putting them out there, getting user data into it, and then discovering that they were not securing the user data effectively, and then leading to a breach of that user data, and of course the problems that ensue from that. So again, the benefits of vibe coding are there, but we're not quite at the point yet where you can just point, click, and then ship. Although there are reasons to believe that the technology is going to move in that direction. So where we are right now, a lot of human involvement is needed in testing. Another aspect of this, again, is what I was talking about on the previous slide of actually needing people that are developers that are able to interact very well with the stakeholders. That is the maybe the quintessential long-term human element of the software development process. Is you have people that either don't know about the software development process, that don't want to spend the time to learn about it, that executives that don't have enough time to spend on any one activity, and so just like they outsource their accounting or they outsource their other activities to staff that perform those, you may have somebody that does development, where their role is to understand what the business needs or what the organization needs, and then actually develop that, meaning that they prompt the AI to do whatever needs to be done, and then take responsibility for testing and assuring what is produced, getting it ready for the organization to actually use. So if we think about this as a kind of potential midterm development model of actually being able to make software, but maybe not making software that's ready for prime time right out of the vibe coding tool. Again, the role of the developer, even right now, is a little bit different. And I think we can all kind of expect that the role and the skill set that developers are going to have in the future is changing somewhat dramatically. So I imagine there are a few students on this presentation or listening to this presentation right now. If you're starting your computing degree, your programming degree, whatever, right now, I would be focusing on making sure you also have really strong communication skills. Technical skills are still going to be important, but the communication skills are going to be probably more important than they ever have been for developer roles, because most developers for small to mid-sized projects are not going to necessarily have the abstraction layer of multiple people, a sales rep, a project manager, etc., in between them and the stakeholders. Their role may be to interact directly with the stakeholders. So again, that's kind of how we can expect the role and the skill set of developers to change. And again, it means that in a lot of cases, what is being taught right now to people in computer science degrees, programming degrees, et cetera, what's in the ACM model curriculum even, is not quite a match for the jobs that are available right now and the jobs that are going to be available when students graduate in 1 or 2 or 3 or 4 or 5 years down the road. So from an educational perspective, it's very important to be kind of thinking, well, where are we aiming for? And of course, this is a moving target, right? If we're trying to create a curriculum for preparing students to be ready for 4 or 5 years down the road, we're probably not going to be trying to prepare them for today's status. We're probably going to be aiming to prepare them for a status that's a little bit down the road, and that's difficult because we're then guessing at how technology is going to change and what the technology is going to transform into in that time. Another really big challenge that we're already beginning to see, and I think this is only going to get worse, is a very big limitation on the roles for junior developers. One of the challenges is that vibe coding, again, it's doing kind of the role of the junior developer. And what it needs is oversight. It needs, a human that can review the code, a human that can do, high level, mid level design work, a human that can look at the results and provide feedback on it. And unfortunately, these are typically not junior developer skills. These are more senior developer skills. And what this means is that we have different training and preparation requirements for people to really enter into junior developer roles. And this may require more and different skills. There's been kind of, I would say, a running joke, but I mean, it's also very, very serious, despite the fact that people joke about it quite a lot in technical job descriptions, which is that, you look at the junior role and it says, okay, all you need is 5 years experience in a technology. And of course, sometimes the joke is you need 5 years experience in a technology that's only a year old. How in the world do you prepare to have 5 years experience in a 1-year-old technology? But I think part of this, not all of this, but part of this is as the tools are getting better and better, development teams are needing people that are more experienced in order to be able to kind of hit the ground running and to be able to contribute. And of course, the job descriptions are reflecting that, where having somebody that is able to maybe do a little bit of development but needs to spend some time kind of doing a lot of kind of development day in and day out before they get to the point where they're comfortable doing it. This is not necessarily going to be somebody that's going to be comfortable doing development assessment or design right off the bat. So the target for what is going to be needed for a junior developer, it seems to me, is shifting pretty significantly as well. And again, this is something that is tricky from an educational perspective. It's tricky from a kind of planning goals, planning educational programs, and it becomes kind of a question of, well, if companies are not necessarily going to be willing to hire people that are at the place where a lot of current graduates are, being maybe very good technically at making applications, but not having the experience or the knowledge and understanding of how to do this in a larger environment, how to use some of the enterprise tools, et cetera, how to use code management, whether there's going to need to be some other mechanism that provides a bridge basically between that current level of knowledge and understanding that people are leaving, whether it's coding boot camps or degree programs or whatever it is with, and the entry point for the workforce. And I think, those that are able to answer that question are going to have a much better time getting students placed than those that aren't. And of course, the challenge here is, again, looking how many years into the future to try to figure out how you're preparing, students to actually get to the point where they're ready to enter the workforce when you're guessing at where the workforce is likely to be at that point. So again, it's an interesting challenge. It's a very, kind of tricky problem in terms of exactly what the best approach is to take that. But certainly it's something where what most places are doing right now is not really preparing people for today, nor is it necessarily preparing them for tomorrow. So kind of an interesting thing to think about, but also something that is really a critical question to resolve and to try to prepare for preparing graduates to enter the workforce. That brings us to the end. I know we're only at about the half-hour mark here, but I wanted to leave a little bit of time for some discussion and some questions. And so I'll kind of open the floor now. First, I guess maybe for questions, and then after we get through the questions, to a more general discussion. So it looks like there's a question in the chat. I'm going to start with that, and then I see 3 hands raised, and then we'll go with that. So the question in the chat is, if the programmer increasingly becomes a system orchestrator, quote unquote, rather than a coder, what new professional skills will define a successful software engineer in the AI native area? Well, that's a difficult question, Prakash. Thank you for starting me with that. I think that I think that is kind of the quintessential question. I think certainly a good technical understanding is needed, because what you don't want to be doing is, promising things that just don't exist. Oh, yes, we can build the rocket to Mars using duct tape and chewing gum. That's not a reasonable, thing to do. It doesn't matter how well you prompt the vibe coding tool to do that. It's not going to be able to do that. So the technical foundations, understanding what the technology does, understanding how the technology does it, are going to be important. For right now, certainly knowing how to fix code when it doesn't work, fix things when they break, is important. But in terms of what needs to be done, in terms of new skills, again, communications is going to be a really big thing. Project management is going to be a really big thing. Understanding how to translate user requirements into prompts that produce kind of what you're expecting is going to be a big thing. And the technology is going to close in on this. Prompting is getting more and more, or the applications are getting better and better at accepting bad prompts and producing good results. We're beginning to see some of the models that will ask questions if they don't think a prompt is specific enough, et cetera. So those are potentially some ways that some of these skills may not need to be quite as intense in the future. But understanding what the human stakeholders want, I think, is always going to be a big thing. And again, I think communications built on and kind of in conjunction with a strong technical background, to understand what how the software works, what the tool does, how the tool works, and then how to fix things when they don't work. But thanks for the great question, Prakash. Let me look at the hands that are raised here. I'll just go down the list. Ganapathy, do you want to go next?
Yeah, I think Ganapathy, he was first to raise the hand.
Yeah.
Yeah,
I think it's ordered them in the list based on the order they were raised.
Yep.
So
I hope you can hear me now.
Yep.
Jeremy, in your experience, what are the best of the emerging vibe coding platforms out there? I have personally have experience with Google Gemini's Canvas, and it's doing really well. But I want to hear what your experience is in terms of the best of the emerging vibe coding tools.
Yeah, I mean, there certainly are a lot of tools. The ones that I have played with personally the most are Cursor and GitHub Copilot. I think both of those work well. I tend to use Cursor. I think an element of that is it's the tool I'm most familiar with, and so it's kind of what I gravitate to just because just because of my familiarity with it. Cursor is kind of interesting in that it uses several different underlying models, including like Claude Code and some other things. But then they also have their own model that that tasks things off or can task things off to different underlying models based upon what you're asking it to do. But again, I think really for any given application and for any given enterprise, there's a lot of different things you need to look at. One of the benefits that GitHub Copilot has is that it will come under many organizations' Microsoft Enterprise Agreement. So it already has like some of the privacy protections and some of the legal things that are needed for some organizations to use it, just like they're already using, say, Microsoft Office or other applications they're getting from Microsoft Teams, et cetera. So each of the applications, I think, has its pros and cons, both technically and from kind of like a logistical, contractual, et cetera, perspective. But I mean, a great question, and yeah, certainly, I think if you're going to begin any new endeavor, it may make sense, or if you haven't done this before and you're just getting kind of into it, it may make sense to try a few of the different tools. And certainly, a lot of the tools offer, either free trials or a limited number of prompts or something, so you can kind of get the hang of it without having to spend a ton of money, signing up for 5 or 6 different tools. But great question, Ganapathy.
Thank you.
Richard, do you want to go next?
Yes, thanks. So I wonder, I'd like to get your thoughts on whether we kind of have a snake eating its tail situation going on. If more coding is going to be done through vibe coding, then your mid-level folks are going to have necessarily eventually less coding experience themselves. So how do you train them to be good evaluators of code and to know where things have gone wrong if they themselves are not growing up and being trained in lots and lots of coding the way we do it now?
Well, and I think that's a big question. My guess is that what we're going to see is that the tools probably move faster at eliminating those types of roles than before we hit that problem. The speed at which these tools are growing in capability is really incredible. I mean, going back, to what some of these tools were doing a year ago or 2 years ago versus what they do right now. I mean, the change is just dramatic. I think what we're going to see over time, with maybe a few exceptions, just like people go in and, some of like the high end games, they go in and they write some assembly because they, a certain thing really needs to be optimized and they don't want to, have a compiler or an IDE or whatever messing with that. And so they write a little bit of assembly. I think we're going to see more and more of programming moving to simply prompting these tools. And, again, it's going to, over time, remove, I think, some of the technical aspects of this as the tools get better, at not creating issues. And I think what we're going to see, is a flip from human oversight of the tools to we need to make sure that we're running the tools or the outputs of the tools through other tools to look for certain types of security issues as those tools get better. And when you get to that point where you can create an entire workflow just by bringing together multiple AI tools and presuming that we can afford the energy and whatnot that's necessary to do this all, and it doesn't cost like $1 billion to make an app with all the different tools we need to run it through. I think we're going to see the development process getting much more human centric, being far more about understanding the requirements, defining the requirements, deconflicting the requirements, as opposed to right now where if you're doing this today, it's about making sure the tool did kind of what you want, giving it feedback, making sure that it didn't do anything horrendously bad with security, and then doing some more fine-grained testing both on the functional and security side. So I guess to kind of circle back to your original question, Richard, I think where we're going to kind of see this in terms of those mid-level positions is that we're going to probably see the tools begin to encroach upon those technical capabilities pretty quickly. We're already seeing like Cursor has a tasking mechanism built into it now, where if you give it something that's too big for it to deal with as a single prompt, the first thing it does is it starts subdividing it into tasks. So it's already kind of doing something that's kind of a team lead role there. And I think we're going to see more and more of that. But great question. Thanks.
Well,
Thanks for the question.
And not to monopolize here, I'll pass it off quickly. But I think that's true. But I think it assumes that these tools are going to get better and better, and that they're not going to embed flaws that people can't recognize, and that we're already hearing that there's tons of kind of sloppy code snippets that are getting out there because people aren't evaluating them carefully enough. And so then they get into the tools, and then the tools propagate them. And it's this whole idea of recursive training and data poisoning and all these other things we can get into. I think you're right. If we can ensure that we're able to monitor those tools correctly and we have the right people to do it, that's the question.
Well, no, and I think that's a good point. And I mean, certainly, there's no shortage of human-generated sloppy code, and again, where did the tools learn it from? They learned it from the humans. But I think the challenge is going to be two things. It's going to be eventually there are going to be so many different things to check for that it becomes kind of daunting for a human to do it. And will we catch everything through? It won't really be a checklist approach, but the bag of tests approach, probably not. But I think we will get a lot of stuff through that, and you'll need a tool to automate that simply because of the scope of different things that can be tested for, should be tested for, and you may begin to see like we see in other industries. If you don't do these 56 tests or these 5,600 tests, you're creating kind of a liability because these are the standard of practice for that. So I mean, it'll be really interesting to see where it goes. Certainly there is some movement right now within some of the AI communities to pay humans to generate good data. And so could you have something where you have humans either creating new code that is designed to be very very clean code, or taking existing code and cleaning it up to try to provide better training data for the models. I think that's a very very realistic thing as well. It'll be interesting to see where it goes. I mean, it's great to guess, but of course the reality becomes whatever the reality is. But thanks again for the great question, Richard. Emmanuel, you had a question or a comment?
Yeah. Oops. Yeah. My question is with respect to the view that tools of this kind are job killers. How do you rate it as a job creator?
Well, I mean, I think that's an interesting question. I mean, I think it's going to be a job shifter. I mean, certainly there are going to be jobs that are not going to be needed, and if people are not able to adapt their skill sets, that's going to be problematic for those individuals. I think the biggest potential, I think, from this is having more opportunity to use bespoke programs for things that they wouldn't have been cost effective for now. And so opening the door to, maybe smaller budget projects where, again, right now you probably couldn't build it with $5,000, but in the future, when what you're buying is a little bit of human time and a lot of AI tool time, it may be more feasible in order to to be able to do that for smaller projects. And that may open the door to a lot of new work for both the humans and the AI. But then again, I mean, I think some of this, in the long term, there are going to be a lot less people that are going to be employed as programmers, unless there is a tremendous growth in the amount of software that's needed. If we can take 5 or 10 programmer roles and compress that down to say 1 or 2, you need a lot more projects in order to offset that, and you need people that are able to to do those more higher level roles, do the project management, do the design, do the technical leadership. And if existing people that are skilled programmers can't transition into those roles, that will also, I think, be a limitation. But I think that's a great point. I don't think that this is something necessarily to be super concerned about from the jobs are going away, but I do think it's something to be super concerned about from are we preparing people for the right jobs right now? And for people that are already working in these jobs, are they beginning, to get, to transition themselves to having the new skills that they want? I was watching. I'm going to space on the name of the movie. It was about the calculators at one of the NASA facilities. Hidden Figures, I think, is the name of the movie. And one of the things that struck me in that, the first is that you had a room of people whose job was to be calculators, right? That's not the way we use the term anymore. But the second thing was that one of the managers there, and I'm not sure how realistic the movie is to reality, but one of the managers identified, hey, we have this new IBM computer coming in, and if that's going to take the jobs of the people in this room, or we can prepare, to be the people that run this computer. And that's what she did, is she prepared her staff to be the people that run the computer, and that's the jobs that they got. So I think that is the opportunity here is for people either through formal education or through their own personal education to try to transition and to prepare to transition into what is the kind of programmer or at least software developer roles of the future. But great question. Thanks, Emmanuel.
Yeah, job shifter, not job destroyer.
Yeah. Definitely. It looks like Caleb, next question.
Yeah, hello. Can you hear me?
Yep.
Sweet. Yeah, so I'm a student here at UND and software engineer, staff member at UND as well. My personal time I've been doing research into vibe coding and LLMs and that kind of stuff. Personally, I found that LLMs are what's running vibe coding, at least like the task of vibe coding under the hood. And so I would assume this would mean that vibe coding would contain like the strengths and the weaknesses that LLMs have. That being said, the things that I see being used to fix the problems that come out of vibe coding are usually stuff that's applied to the end. For example, changing the prompt, which would usually mean that we're not actually changing the root cause of the problem because we don't really know yet what the root cause of the problem is. So I'm just wondering that if we are still using LLMs, is LLMs really the tool that we're looking for, being that LLMs are more of like a tool to generate human language rather than computer language?
Well, I mean, so certainly, programming code has similar characteristics to the type of human human readable language that LLMs kind of were first used on, and in certain ways, because of their syntax, because of the requirements that go with them, they are maybe a bit more predictable than something a human might write. So I think in that regard, the kind of predictive capability, seeing a sequence, figuring out what the next logical thing in a sequence is, that LLMs are very good at, makes a lot of sense. It's something that can be applied to this area. What we're seeing with LLMs is that most things that we call an LLM are really not an LLM anymore. They're a hybrid model. So, like, if you look at the most recent version of ChatGPT or Claude or whatnot, these are really quite a lot of different AI techniques being kind of pulled together. LLMs were not doing very well at math for quite some time, and now most of the current models are able to do math quite well. And so that we're seeing the ability of the different developers to make their models better by bringing in existing techniques or developing new techniques. I mean, computers have been doing math well for quite some time, so it was kind of ironic that the thing that the LLMs couldn't do very well for a while was math, because that's kind of the quintessential thing that computers were actually quite good at. In terms of the question of, well, are LLMs really the right technology for the future of this? I think there's a lot that has to come together. I mean, one of the challenges that LLMs have is that they don't really have a what some people call like a deep understanding. It's very superficial, and that can create problems. That creates security problems. It creates API mismatch problems. There's also the hallucination issues that we see occasionally, and certainly, some of the tool vendors are doing things to try to prevent that. They're checking to make sure APIs actually exist after the fact, like you mentioned, and doing reprocessing. But I think what we're going to see in the longer term is, again, more and more different types of AI technologies being brought together to actually produce a more robust and more capable thing. We'll probably still keep calling it a model, even though that may not be a totally appropriate name for it, as more and more things are leveraged for it. But great question, Caleb, and thanks so much for asking. It looks like Tom is next.
Hey, Jeremy, thanks for doing this.
Yeah, glad to.
So I do 160 first class for majors, right? And looking forward, am I going to turn into teaching coding to teaching? I mean, instead of writing code, we're writing prompts. Okay.
Well, I think that's the question, right? I mean, I think the way that I would approach this, the way that I kind of think makes the most sense, is introducing students to vibe coding early. The first thing is, of course, they're all going to be doing it no matter what you do. So at least you can teach them what they're doing, as opposed to, trying to give them difficult assignments and then just go type it into something and then turn it back in 2 minutes later. But I think, we for people that are going to be in that in that technical role of needing to understand how coding is done, how to fix it when it breaks, they definitely need to have some experience coding. And it's kind of like the way when teaching kind of early levels of math, the teacher doesn't let students use calculators for a bit. You have to understand how to do addition, how to do subtraction, how to do division, multiplication, etc., before you automate that with the tool. So I'm not sure, I think we're going to see students that are coming into computer science and programming programs with more and more coding experience. So what the first college level course needs to do, I think, is going to maybe be something that changes over time. But, I think certainly we're somewhere at some time, students need to learn how to actually do programming on their own and then translate that into, what does this mean when I'm using the tools? And exactly when, where, and how, I think is kind of a big question on that.
Well, my concern right now is everybody who's so effectively using these tools is, for lack of a better term, what I want to call late AI. AI was introduced very late into the process. They have a solid grasp of computer science fundamentals. Okay, we're creating a new generation of computer scientists that are early AI. It's being introduced very early in the process, and they're not going to have that solid background. I think of Kernighan's law. and it takes twice as long to debug as it does to write. Well, as writing goes to zero, Kernighan's law is going to go to infinity. Uh,
Yeah.
the people that don't know how to write the code are going to be the people responsible for modifying the code.
No, I mean, I think that's a challenge. I mean, I think, the positive view on this is if we start students at a higher level, that means that they can go further. And you're just like, most computer science programs have moved away from teaching assembly, moved away from teaching early generation languages. And now, a lot of programs start with something like a C or a Java or a Python, that is a more advanced language than, let's figure out how to write stuff in assembly. It's tricky because we definitely need people that understand how the underlying aspects work. We still need people that even understand how assembly works or how processors work. But those become maybe more niche and more specialized skills that less people need to do, and more people now are learning how to communicate with the stakeholders, how to translate that into prompts, how to fight with the prompts when they don't do what they want, and then how to debug when things go really wrong. But I think you may have roles of senior developer or super senior developer, where if the person that normally is doing the debugging can't figure it out, you have to go to somebody that has been more immersed to do that. And over time it may be more difficult to find people that have that skill set as they grow older, are not that interested in that type of role, maybe retire, etc. So I mean, it is a challenge, but it's not that different from the challenges that have been faced previously in technology. It's just we're facing it now in this particular area.
Yeah, those people you are referring to are probably also know how to program in COBOL.
Well, yeah. But on a positive note, the tools now can translate like a C program into a COBOL program. So we're back to being able to program in the older languages as well. So I mean, there are pros and cons here. But
Thanks.
yeah, it looks like another question from Richard. Do vibe code tools confabulate like GPTs? I think it sounds like Richard had to leave, but yeah, I mean, in a lot of cases, they are built upon GPTs, so they would have the the same issues, same benefits, same limitations of them. So I don't know, Richard, if you're still connected or not, but I would say it is very possible, and certainly understanding the failure modes of these things is very important. Understanding kind of how they can go wrong, and so it is important to kind of understand that stuff. But thanks for the follow up question, Richard. Any other questions? Any other comments? Anything anybody wants to discuss?
Yeah, Jeremy, this is absolutely wonderful. I was thinking the soft skills are going to be more and more important, right? That business analyst piece, right? Going out there, talking to the people, getting that information out of them to put it into vibe coding or whatever it's going to be called down the road is going to be very important. Where my head was going is, so we have all these mom and pop shops, software companies who want to sell things for us, right? So I'm thinking, okay, we should be asking them, how did you even build this thing? Right?
Yeah, I mean, it's tricky, and I mean, certainly, in a role where you're buying software too, figuring out what the due diligence is that's required now is probably different than it was even a year or two ago, where you can have an entity that can quite truthfully tell you, well, we're not aware of any issues, but the answer may be that they're not aware because they haven't looked at all. And of course, if no humans looked at it, they can truthfully say that nobody in the whole company knows of an issue, because no human has looked. So certainly that's another area, and another kind of complementary skill set to the to the, I don't know what you want to call it, the developer side communicator, the buyer or stakeholder side evaluator communicator, is another big role, and certainly something that needs to be thought about. So great point.
All right, any other questions?
Oh, it looks like Ganapathy. You got another one?
Yeah, this is a question that's going to come up no matter what. Where does the liability reside when you use tools like vibe coding? Is it eventually the person who markets it or who certifies it? How is the liability going to be handled with things done partially vibe coding, partially human?
No, and that's a great point. And Ganapathy, I don't know if you've heard me say this, but I use this expression frequently. If we built buildings the way we build software, we'd have a lot of injured people because the buildings would be falling over, right? The software industry is not at the same level of rigor as other areas in engineering, other areas. And so the question of liability, I mean, one is how do we reduce the number of things that can go wrong and try to reduce the liability, but then also who is on the hook when something does go wrong. And I think we're going to see a lot of this in the courts. I don't think this is an answered question. One of the challenges is that an agreement between party A and party B doesn't necessarily prevent party C from suing party A. And so, particularly if you have a small company that buys a tool from a big company, small company goes out of business. Yes, the small company has agreed to indemnify the big company, but here's the problem: the small company isn't there anymore to do it. So I think we're going to see, really, a lot of lawsuits about this. I think we're going to probably see laws put in place. Some of the big companies that are selling these tools are probably not going to want to be on the hook for this type of stuff. Again, it will be a question of the contracts. Like it looks like Nicola, apologize if I mispronounced your name, just mentioned look at the contracts in the chat. That's going to be one big thing. But also, when you think about like lawyers and who gets sued, it's also look for who has the deep pockets, right? Because those are going to be the attractive targets for people to go after. Going after a small business, or going after a single individual, or going after a business that's out of business, there's no money there. So lawyers aren't going to spend tons of time and effort going after places that they're not going to be able to get a judgment from. And so I think we're gonna see a lot of interesting stuff in this space. So it's gonna be interesting to see. Hopefully, it will also result in a greater level of diligence being applied to software, more akin to what is applied to lots of other areas. Because certainly, software is doing stuff that is as crucial as having a building to protect you from the elements and having a building that doesn't fall on you. And as we have software that's in these key roles, we need to expect more of it. We need to expect it to be as reliable as other systems, as our water, as our power, as our construction, et cetera. So I think the liability question here may also be something that maybe drives higher quality finally in the coding industry and the software industry. But great question. Thanks, Ganapathy.
Thank you, Jeremy. Thank you.
It's almost like we have to include this in our contracts as well, some standard language to go in with every contract now.
Well, and then, and again, who's holding the bag? I mean,
right.
It's one thing if the contract's with Microsoft and you can kind of guess, again, it's a lot could go wrong, right? I mean, if everybody sues a big company at once, sometimes the big company doesn't exist anymore. But, then if you're dealing with a contract with a smaller entity, and that smaller entity, even if they agree to indemnify or they agree to do certain things, if they're not able to do it, if they don't have the fiscal ability to do it, that may not amount to much. And, then you get into the question of, is there insurance available? And then, is the insurance company on the hook, and now also trying to get involved in terms of preventing themselves from having a successful claim against them by again trying to improve the quality, or at least ensure that they understand the quality. So very interesting space, and again, we're going to see a lot going on in this space in the next few years.
All right, I don't see any hands up. Last call. Thank you, Jeremy. This is very eye-opening for everybody. Yes, I say, yeah, great presentation. Again, thank you very much. This is very, very useful for students as well as us educators and the people who buy stuff on a daily basis as well. So our next AI forum is going to be on February 10th, I do believe. And we are going to bring back a previous speaker to talk about Copilot agents. So if you may recall, about a year ago, we talked about Copilot and how to use Copilot. But this round, we are going to talk about the agents. What can you do with the agents? How can you create the agents? And how are other people using agents as well? So I hope all of you will be able to join us again, February 10th. That's a Tuesday, as usual. Thank you again. Have a wonderful beginning of the school year, semester.